I have on the board sort of a few things that we need to cover today. Before I even get to those, I did a whole bunch of marking actually this morning. I found some time. So at some point today, you need to check your Schoology account, check your grade on there. There are some things that people have not handed in. I've got several. I have several of the Galileo labs in. Joey and Zach, I have these ones that were from way before. I have them for you. I have the Galileo labs. I have one from O'Reilly, but I don't know which one, so one of you guys need to come see me in a bit. These are all grouped. Like I put a mark in for every group. I have the what I like to call the Johnny Physics little assignment where you have to draw the graphs. Okay, I have those marked. And I have the sideways kinematics ones, people that handed those in. I have those marked. So at some point today, you need to go into Schoology. You need to check to see what you are missing.
You could roll all that part.
I have not. That was actually due today. Okay, it was due today so that I can get it back to you prior to the test, because basically this is the test outline. Okay. So you need to get those in. There's also the online quiz that some of you have not completed either. Okay? Those were the things you guys were supposed to be working on yesterday a little bit. All right, the first thing that I want to go over, it was asked for me to go over there the other day, is this one here. And I asked you to complete this on your own. So no doubt you guys diligently did that, of course, because that's what students do. And so I will just quickly go through these. So if you could find this one, I'll pause here while you guys are finding it. Okay, so positive velocity, negative acceleration. Now you'll notice down here, positive velocity, negative acceleration. Positive velocity means that it's moving to the right. Negative acceleration means that the acceleration is to the left, and so this object is going to be slowing down. And we can see that it's slowing down because the dots are getting closer, which means that the position time graph is steep at the start, and then it flattens off, okay, because it's slowing down. The velocity starts at a high rate and goes at a steady straight line down to 0 because it stops. And then the corresponding acceleration is flat, okay, because it's the slope of the velocity time graph. The next one. Well, see, this is why I actually do it ahead of time, on your own. Well, you had time. You had like almost a week, Hannah, to do it. You guys have to do these things. No, you can't just do physics in physics class. It doesn't work like that. I'm moving on. Negative velocity, negative acceleration means that it's moving to the left. Negative acceleration to the left, so because the both sides are the same, it's actually doing what? Say speeding up or slowing down. Which one of those two? Speeding up. So when the signs are the same, it's going to be speeding up. And because they're both negative in this case, it's speeding up to the left. Now, because it's going left, the position time graph occurs in the negative area. It's speeding up, and so that means that the slope is increasing in a negative sense because it's negative velocity. The velocity time graph is increasing, i.e. the velocity is going from 0 to about minus 20. Okay, so it's down like this. It's in the negative area because it's to the left. And the slope is constant because it's speeding up at a constant rate. And because the slope of this line is negative, the value of the acceleration is also negative. It's about minus 1.5 or so on the acceleration time graph. Okay? I will post this all up online. You can check it later, too. So that's what we're supposed to be doing right now, is checking, not copying down. Go to the next slide, please. Here we go. This is the next one. Now, I skipped one, didn't I? Which one am I skipping? Oh, okay. My apologies. This is the one?
Yep.
Negative velocity, positive acceleration. Negative velocity means that it's moving which way, left or right? Left. Positive acceleration means that the acceleration is to the right, which means that this object is going to slow down. So it's moving left, but slowing down. The position time graph, because it's moving left, is still in the negative region. Why is it flattening off like this? Because it's slowing down. Slowing down. The velocity time graph is in the negative region because it's moving to the left, and it approaches zero. Why does it approach zero? Because it's slowing down. The slope of the velocity time graph is positive, as you can see here, and so the value of the acceleration time graph is still flat because the slope is constant. It's flat and it's positive. Okay, the last one here. This one you probably don't need to draw. Let's just sort of discuss it a little bit here. So first of all, up top we see a blue car and then a red car appears on the left. Which car is traveling faster? Clearly it's the red one. Now, can you tell from the graph that the red one is also traveling faster? How do you tell?
Because that's
Steeper slope, exactly. Can you tell me where the red car passes the blue car?
60.
How can you tell?
Because they intersect.
That's where they intersect, exactly. Okay, it looks like it's at 60 and the time is 7 seconds. Anything else you can tell about both cars? Can you tell how far the blue car goes? Up to 10 seconds, like not after the 10 seconds. It looks like it goes 80 meters, right? Can you tell how far the red one goes? 120. Can you tell how fast numerically the blue car is going? How would you do it?
8 meters per second.
I don't know. How would you do it, Jordan? Just tell me what would be the steps. How would you find out how fast the blue car is going? Starts with S, ends in. Thank you. It's the slope. We would find the slope of the blue line. Would that not give me the velocity? And the slope of the red line would obviously be the slope of the red car, right? Okay, now, what do you think the velocity time graph for those things looks like? What would you guess or deduce or come up with? Would it be curvy? Would it be straight? Would it be flat? Steve says it should be flat. Chris? Oh, you're just agreeing with him? Oh, okay, sorry. Flat, everyone?
Yeah.
Why flat? Yeah, constant speed. Go to the next slide. There's the position time graph on top as well, and there's the velocity time graph. Is that what you expected?
Yeah.
You probably expected that the red one would come all the way there, though, didn't you? Why does it not do that? Because we don't see it until 4 seconds. It's sort of happening off to the left there, right? Can you tell from the bottom graph here, the velocity time graph, can you tell which one's going faster? How can you tell? The red one, because it's higher. Can you tell me which one is accelerating more? Which one's speeding up faster? Jake's going bold and he's saying neither. Joey's texting. Find out the answer. What's the answer, Joey? Is it red, blue, or is it neither? Why?
Because going at constant speed.
They're both going at a constant speed, exactly. We can say for sure that they're both going at constant speed. We can tell that because the slopes here are constant and because these lines are flat. Not straight, flat. These are straight too, are they not? These are flat. In fact, what is the acceleration? Without even calculating, you should be able to tell me that the acceleration is? Zero. Can you tell me from the bottom graph where the red car passes the blue car? I heard and saw a lot of no's. Riley, what do you think? Can you tell from the bottom graph where the red car passes the blue car? Why do you say no? They're not showing position, that's right. However, I will respectfully disagree with you that I can tell where the velocity and where the positions are the same. How do you find displacement from a velocity time graph? You do the stuff. Oh, hang on here. I gotta. How do you find displacement from velocity time graph? Don't you find the area? What we know that they cross where? At 7 seconds. So if I went right there and I took, which one's the blue here? If I got all this blue up to there and calculated the area of all that red up to there, what would they both be? They'd be the same. In fact, they would be 60, would they not? So would it be easy to tell? No. You'd have to like pick 1 second and then 2 seconds and then 3 seconds and check, and if it was somewhere in between, you'd have to guess. And really, you can do some calculus here to figure it out. But it is possible. Is it possible for the average grade 11 student? No. Will I expect you to be able to do that?
No.
I might expect you to say, do they cross each other at 6 seconds or 8 seconds? Give you two possibilities. You have to figure out the displacements and see which one are equal. That doesn't seem out of line, right? Like if I gave you choices of 7 seconds and, I don't know, 6 seconds, could you do that? Right? You'd have to find that black bit there, and you'd have to find that black bit there, and see if they're equal. You could do that, couldn't you? Why not? It's finding the area of two rectangles and seeing which ones are equal. That's all it is. Okay, so I might expect to be able to do that. Okay. Okay, what else do we need to go over? Let's talk about the word problems. How have those been going? Fine. Thumbs up. The word problems. You should have got another set yesterday. Did you get another set yesterday? You didn't? Oh. Okay. I have here, if you would like another set of word problems, and I highly recommend that you do, take one of these and pass them around. Okay, if you're away and you're listening at home right now, you need to come get that sheet. Once again, there are answers on the back. There are detailed solutions in the red binder, and there's a QR code for you as well. And I think that the link is on Schoology as well. If it's not, send me an email and I'll fix it.
Are the acceleration and beginning pneumatics questions handed?
Does it say handed on the top, George?
No.
Then it's not.
Okay.
Am I going to have to say for every sheet for you?
No, I know these ones are.
Okay, so nobody needs me to do any word problems. Everybody's good there?
Yeah.
Well,
Yeah? You can come and see me on individual questions if you have. The solutions are on the red binder. There's QR code and everything. Okay. The hand-in kinematics hand-in and test outline. Steve asked about a test outline. That's different. Let me just see if I have one made or if we're going to have to make it. The question is, can I go through this backwards? Of course. Well, it's not can I, it's can I go through it with you. How to go through it backwards. Okay, so go ahead and give me an acceleration. Make something up that I can work with in my head. That's not going to confuse everybody. Not 1, 1 is way too simple.
2.5.
2.5 is a good one. Okay? I'm going to work through this backwards, Hannah. That's been requested.
Why are you throwing me in there? I didn't say anything.
You said, what's this?
No, that says Peyton. That was me.
Peyton, this is the chart that I'm going to go through backwards. Because someone asked me to do it. And it's probably not going to hurt you. So
Are you
listen.
going to have to go through backwards on the test?
Yes, one of the questions on the test is what?
Go through this backwards.
Were you guys not here for that? When I said one of the questions, it's going to be a group question, is to go through this backwards. I said that. You really got to start listening to my voice. Because I say important things like, is this for hand-in or not? And when is it due? And you should do this on your own. I'm kind of the guy that has all that information. You should listen when I say it. Go ahead, Jason.
Can you do one when like the time intervals is more than 1?
Yeah, you should.
I will give you a small example. Okay, if the average acceleration is 2.5, tell me in words, what does that mean? Keelan. Yeah, no, come on. What does it mean? It means that and don't say the average acceleration is 2.5. Don't just regurgitate it back to me. What does it mean in terms of the velocity? The velocity is 2.5? What does acceleration really mean? It means how fast the velocity is changing. So if I said, what does it mean in terms of velocity? If the average acceleration is 2.5 meters per second, it means that the velocity is changing by 2.5 meters per second every second, or squared. It means that the velocity is changing by 2.5 meters per second every second. If was it 10, a second later it's going to be 12 and a half. Okay, so if my time interval is from 0 to 2, my time value is now 2 seconds, correct? Okay, what's the formula for acceleration? Delta V over delta T. We've done word problems with this. What is the acceleration? 2.5. By the way, many of you handed in some stuff without formulas on it. This sideways one here. You have been deducted marks. Show the formula. Stop being lazy. I'll hand those back tomorrow. I don't know the change in velocity. That's what I'm trying to find, delta V. What is my time? 2. Now, grade 11 physics students should have a math background where they can solve that in their head. How do you get rid of the divide by 2? Multiply both sides by 2. The right-hand side, you have delta V. On the left-hand side, you have 5. You need to be able to do that in your head at this point in your science math career. If you can't, I'll give you some practice questions. Come and see me. So, what do I write under change in velocity? Now, we only know that the position at the start of the interval is 0. Can we assume that the object is at rest? Whoopsie. Can we assume it's at rest? We're going to have to, because otherwise we can't do it. Right? However, if I give you a number in there, you might have to be able to deal with that. Like if I put the number, or 10 I was going to put just because it's easy to fix, right? You're going to have to be able to deal with that. Okay? For now, let's leave it at 0. Okay. Now, if the instantaneous velocity at the start is 0, and the change in the velocity is 5, what is the value at the end? 5. Jason's already answered the question, even though I haven't asked it yet. What's the average velocity? 2.5. Excellent, Jason. He's a mind reader. Okay, now, why is the average 2.5? Between 0 and 5. The average is 2.5. Now, what if, just for fun, because I'm a big meanie, what if I start the thing moving at 10 meters per second and the change in the velocity is 5? What would be the instantaneous velocity at the end now? I'll say the question again. If I start the velocity at 10 and I change it by 5, what is the velocity at the end? You said it. You said it right. Is it not 15? Right? If I start, I was part of used to, yeah. If I start at 10 and I change by 5, then I have to end up at 15.
What if you change my time to
Then it would be a negative 5 here. Good question, though. What would be the new average, Jason, between 10 and 15? Would it not? Not? Yeah, okay, I can do that. Yeah, see, you guys can do this. Okay, now, just for fun, let's leave it like this. If I started at 0 and I averaged 12.5 meters per second, how far do I go? Steve says 25. You might not be able to do that in your head without some sort of visual aid, so let me write that down for you. The average velocity we've said to be 12.5. We are solving for the displacement. And what is my time interval? They're all from?
So when solving for that table, do you want us to write equations like that?
Well, I mean, you should probably show your work, right? Will I expect you to show your work for every single one? No. Am I going to give you like 6 rows like that? Because, I mean, really, once you've done it for a couple, it's just kind of, yeah, right? I mean, it's more for the graphing kind of thing. Don't care about that. Can Steve solve that in his head? I hope the rest of you can. 12.5 equals d over 2. Something divided by 2 is 12.5. That something is? 25. So the distance traveled is 25. And if I started at 0 and I traveled a total distance of 25, then I must end up at 25. Must I not? How do I go down to the next row? Well, I'm going to assume that the average acceleration remains the same. The position at the start of the interval is now 25 because that's where it ended up. Okay, now that's about all I can do over here, right? What's my change in velocity? If my average acceleration is still 2.5 and my time interval is? This should be a 2 here, shouldn't it? Right? The time interval is going to be 2 again. What's my change in velocity going to be? Still be the same. What's my instantaneous velocity at the start? Well, I ended up at 15. If I start at 15 and I change by plus 5, then I have to end up at 20. And if I'm starting at 15 and ending at 20, my average must be 17.5. And if I average 17.5 over 2 seconds, how far do I go? 35. And if I started at 25 and I travel a distance of 35, where am I at?
So how did we get the change in velocity of 5 again? 2.5?
Right here. Yeah, right here, right? What I think I'm going to do is I'm going to give you guys the rest of this period to get cleaned up some things, get some stuff handed in, maybe put your binder back in order, that type of thing. Okay? Tomorrow I'll do a test outline we'll do it as a group together some way, and I'll give you an opportunity to do your cheat sheet as well. Keeping in mind that the test is Friday. Please don't anybody wander into it. I didn't know there was a test. I know you won't. We have to talk. You and Ryan, right?
You guys gotta do it on Thursday now.
It's